Yes, so today we'll learn about carbohydrate, the summary of carbohydrates. So the first thing that you must to know about the carbohydrates is they are general molecular formula. It is CH2O, and their ratio of the elements carbon ratio, hydrogen ratio, oxygen is 1:2:1. Forgot to put N here. Okay. And then they are divided into three classes of the carbohydrates. The first one is the monomer of the carbohydrates. Alright. The monomer of the carbohydrates is known as the monosaccharide. So mono means one, di means two, and then poly means more than two. They are polymers of carbohydrates. The combination of the monosaccharide that links to the disaccharides. So the disaccharides is like an intermediate. Under the monosaccharides, there are two type of sugar, like which are based on their functional groups. There are aldose sugar and ketose sugar. So aldose is because their functional group is aldehyde. Ketose is because they are ketones. So I will draw the functional group of the aldehyde, C double bond O H. This is side chain. And then for the ketones, it is C double bond O, side change. It could be another carbons here, another carbons. So highlights, this is the aldehyde functional groups. And then we have several examples of the monosaccharides, which are triose, tetrose, pentose, hexose. But here we're gonna focus on next three types of monosaccharide. The first one is the triose. As an example is the glyceraldehyde, G3P, and then they are functioning in the photosynthesis and the respiration process. And the next one we have pentose, which is a 5-carbon sugar. Pent means pentagon, so they are ending with the words OSE. OSE means they are referring to the monosaccharide. Other examples are mannose, dextrose. So pentose, a 5-carbon sugar, is the components of nucleotides, coenzymes components, and ATPs, energy components, in the adenosine triphosphate molecule. And then the last one is the hexose. Hex means sixth, so this is a 6-carbon sugar, which is referring to the glucose. So what are the function of the glucose or hexose? There are substrates in the respiration process, and they are the main source of the energy and also energy and carbons for most of the plants and animals. So we have two examples of the cyclic monosaccharides, which are furanose and pyranose. So furanose is a 5-carbon, and then pyranose is 6-carbon cyclic monosaccharides. So we'll look at the firstly. Before we enter the parts of disaccharide, we have to understand the structure of the glucose. So glucose is one of the optically active sugar, because they can rotate in plane polarized on the both side, on the right, to the left. So they have two isomer for glucose. We have D isomer and L isomer. So D referring to the dextrorotatory, and L referring to the levorotatory. Negative D positive to the right, L negative anti-clockwise or counterclockwise. So let's look at the structure of glucose. There are 6 carbon longest chain. Sorry, it is worse. So we will be using Fisher projections, a vertical presentation of the carbon backbone. So assuming this is the first carbon at the top, so this is the first carbon, the one with functional group of the aldehyde, C double H. So we know that glucose is a type of aldose sugar because it having a aldehyde functional group, and then putting hydroxide group here on the right, and then on the left OH, OH, OH. This is H actually, but we didn't put. If you want to put it, it's also can. So second carbon here, third carbon, fourth, fifth, and the sixth, the last carbon. So this is the last carbon. We will determine whether it is B glucose or L glucose by referring to the location or position of the hydroxy group OH, the substituent. If the OH or the substituent locates at the second last carbon, which is this is 1, and then this is the second last carbon, this OH located on the right side, so it is a type of D isomer of glucose. But if the OH locates on the right, on the left hand side here, it is L isomer. That's all. Now we understand the structure of the glucose. Next we will move on to the disaccharide. So a disaccharide having a molecular formula of C12H22O11, and there are 3 examples that are very popular. The first one is the maltose, sucrose, and lactose. So I'm gonna share with you how to remember this by acronyms. So we have TFT plus T plus T plus T. We produce MSL. So this is monosaccharides, and then this is a disaccharides. So how to remember by the acronyms? Okay, so for this one I use Malay words, which is girlfriend, gila, di majlis sukan London. Yes. So the first T here referring to the glucose plus glucose, you get maltose, and then the second one here, fructose plus glucose, you will get sucrose. And then the last one is glucose plus galactose, you get lactose. So that's very easy, an easier way for you to remember about monosaccharide and disaccharide at the same time, simultaneously. And then we'll look at the polysaccharide, which is the polymers of the carbohydrates. They are molecular formula are C6H10O5 close the bracket times N. And referring or denoting any elements, any numbers, integers like 2, 3, and so on. So the polysaccharide, we also have 3 very famous examples like starch. We have starch, glycogen, and cellulose. But the one that are indigestible are cellulose